All right, boys and girls, welcome back to the drive-through. Hungry? Stop by the deli. Make yourself another Philly cheesesteak sandwich. All right, so this is starting to get pretty complicated. It's a simple task, and I hope that I can explain it to you so that you understand why the equation is what it is. Let me start by just giving you this. The distance between a point and a plane can be defined as the magnitude of the projection of some vector PQ on to the vector that is normal to the plane. Okay? Now, another thing that we found out in 10.3 was that the magnitude of the projection of one vector onto the other was equal to the absolute value of the dot product between the vectors divided by the magnitude of the normal vector. So that is what I'm going to try to explain to you guys, and then we'll do an example. So imagine for a second that you got some plane with some point Q, okay? And we want to know how far this point is from this plane. Well, remember that when we measure distance, distance is defined in geometry as the shortest possible measurement between two objects. So that's what we're looking for right there. We are looking for that. Now, if you remember, this plane is defined by some normal vector that is orthogonal to the plane. So now you start to realize that that pink dashed line and that normal vector are parallel to each other, and that becomes an important part. So if we know some point in the plane P, okay, which we're going to know that because that's part of what defines the plane, and we know the vector that is orthogonal to the plane that defines the plane N. Well, here's how we're going to do this. We can draw a vector between P and Q. Okay? And now maybe you can remember that if we took this flashlight, let's say we took a flashlight right here, and shined it, that the projection of PQ onto N would be the amount of PQ, okay, in the N direction. It'd be like the shadow. Hopefully you guys kind of remember that. That's how we do projections. Okay, so what we need to do to find this pink distance between Q and the plane is take the projection of PQ onto N right here and find its magnitude. Okay? And that's going to be the distance because we're talking about a distance. So all we want is its magnitude, which is why we're taking its magnitude. Now, an easier way to do that is just to use that equation. Okay? So we'll get to that, but that's something that you're going to want to write down in your notes for sure and put to memory. So let's do an example. Find the distance between Q, which is 1, 5, -4, and the plane defined by 3x minus y plus 2z equals 6. Okay, so, you know, just, it doesn't hurt to just sketch this randomly. So here's our plane, and here's our point Q, just redrawing the same picture. That's what we're looking for. Remember, we measure that as a perpendicular. Okay, so we're going to say that we want the magnitude of PQ dot N, sorry, not the magnitude, the absolute value, because we're measuring a distance, and the dot product can end up being negative, so that's why we're taking the absolute value over the magnitude of N. So really, we just kind of go through the math. Oh, hold on, we need to find this point P. So how can we find a point in the plane? It's actually easier than you would think. You just, use your brilliant math skills and deduce that, let's see, 3 times 2 is 6. Oh, well, that's the easiest point I could find. But what if I use the point 0, comma, negative 6, comma, 0? Well, guess what? You'd be fine. And what if you use the point 0, comma, 0, comma, 3? You would be just fine as well. But here's what I want you to understand. When you look up your answers in the back of the book, you will not necessarily, oh yes you will. Sorry, you won't always get the same equation for a plane, but you certainly have to get the same distance. So, PQ is going to be defined as, alright, again, we are using this point. So, 1 minus 2 is negative 1. 5 minus 0 is 5. Negative 4 minus 0 is negative 4. So that is PQ. So PQ dot N. Alright, N is 3, negative 1, 2. So PQ dot N is negative 3. Minus 5, minus 8. The magnitude of N is going to be 9 plus 1 plus 4, so radical 14. So you just can leave that as, excuse me, got to have absolute value there. Let's see, 16 over radical 14 is the distance between the point and the plane. So what we did, we found this. And then we found the projection of PQ onto N. That's this. And that is the same as that. Boom!